So hi everyone, I'm Jai. In the previous session, we have discussed what is framing and its different types. We have also discussed one type of framing, that is fixed size framing, in the last session. Today we are going to continue our discussion on framing. We will be discussing the remaining types of framing. So let's start. Now we know that the framing is generally divided into two types. The first one is fixed size framing and the second one is variable size framing. In the fixed size framing, we have seen that the size of the frame is fixed, let's say 5 bits. So receiver can easily understand that the size of the frame is 5 bits, so it will receive every 5 bits and it will consider every 5 bit as a one frame. There were many disadvantages of the fixed size framing, so there are other methods available too. These are the variable size framing. The variable size framing is further divided into three types. The first one is the character count method. The second one is byte stuffing and the last one is bit stuffing. Now let's see what is character count. Now in the character count method, hear me students, in the character count method, the first character of the frame tells you the size of the frame. You can see that in this figure, this is the first character of the frame and the value of the first character is 5. So the first character of the frame tells the size of the frame. It means how many characters are there in the frame. So the first character is 5. It means this frame is having total how many characters? 5 characters. So this is our frame 1. After the frame 1 is received, the receiver will check again the first character. Again receiver will check the first character. Again receiver has found that the value of the first character is 5. So from that, receiver gets to know that there are total 5 characters in the frame. So receiver will receive 5 characters. Receiver will receive 5 characters in frame and it will consider as the next frame. So same concept goes on. Okay, again you can see that after 5 character is received, then receiver will receive the first character of the next frame. Again from the first character, receiver knows that there are total how many characters? 8 characters. There are total 8 characters are there in the frame. So receiver will receive these 8 characters and it will consider as frame 3. But in this situation we are not considering any error. In the real life scenario, there will be error present. Now what will happen if the error is added in the frame? Okay, like suppose the sender has sent this data, but due to error the value of some character in the frame is changed. Now let's see what happens if the value of character in the frame is changed. So you can see that now this case we are taking as situation of error. Like what happens when there is a error in the frame. So you can see that now the receiver is receiving the first character. Because the value of the first character is 5, receiver knows that there are total 5 characters of the frame in the frame. So it will receive 5 characters and it will consider as one frame. Now the receiver is receiving the next character and the value of the next character is 7. But if you see, when the sender sent the data, the first character of the frame was 5. It means in this frame 2 there are total 5 characters and the first character is 5, which indicates the total number of characters in frame. But because of the noise, the value of the first character of the second frame is changed from 5 to 7. Now it is problematic, right? Why it is problematic? Because now receiver doesn't know that the error is added. What receiver will do? It will simply just check the first character of the frame that it has received and the value of the first character is 7. So receiver is going to think that there are total 7 characters in the frame 2, but actually there were not 7 characters, there were only 5 characters. Now see, because of only one character is damaged, only one character is corrupted, the whole sequence will be corrupted. How? Let's see that after that the first character of the next frame is 1. So receiver is going to see that in the next character there is only a size of the frame is only one character. So it will consider as the next frame as a one character. But actually the next frame, the frame 3 is it has 8 characters. Okay, so using counter method is very easy, but if the noise is added it gets so complicated and the whole stream of bit is get corrupt. But if there is an error, the whole stream of characters will get corrupted. Okay, so it is the biggest disadvantage of using the character count method. Now let's see the next method, which is byte stuffing. In the byte stuffing, we will add flag at the starting and the ending of the frame. So you can see that the flag is added at the starting and the ending of the frame. The pattern of the flag is also fixed, which is 0 1 1 1 1 0. You can see that the pattern of the flag is fixed. Now what is the advantage of adding flag at the starting and the ending of the frame? So from the flag, from the 0 1 1 1 1 0, receiver knows that this is the starting of the frame, and from 0 1 1 1 1 0, it knows that this is the ending of the frame. So using the flag, receiver can understand the starting and the ending of the frame so that frame can be received successfully. But wait, this method is not perfect. But this method is having some disadvantages. Now what could be the disadvantage? Now what happens if in the frame flag like data is present? For example, in the middle of the frame, the flag like data, which is 0 1 1 1 0 is present. Now actually it is the data which is present in the frame, but this data is exactly like the flag. So when this type of frame is received by the receiver, when receiver receives the flag, it knows that this is the starting of the frame and it will start receiving the frame. But when receiver encounters this flag like pattern in the frame, receiver is going to think that the frame is till here. So the frame will be broken and it will get corrupted. So you know that now the byte stuffing is having some disadvantages, but there are some methods using which we can eliminate this thing in the byte stuffing. Okay, like we just discussed that what if the flag like bit pattern occurs in the data. So now we are going to see what if the flag like data, the flag like pattern is there in the frame, what we can do. Now you can see that on the screen there is a flag at the starting of the frame and there is a flag at the ending of the frame. Okay, now let's see what is the meaning of byte stuffing. You can see that right now this is our actual frame, and you can see that in the frame there is actually data which is exactly like the flag is present in the frame. So when the data which is like the flag is present in the frame, you know that it is a problematic. So the sender will not send this data directly. Before sending, the sender will add some extra value so that the receiver can understand that the flag like data is actually data in the frame, it is not a flag. So what the sender will do? Sender will add some extra escape character just before the flag like data. So the value of the escape character is different from the flag, and when this type of data is received by the receiver and when the receiver encounters the escape character, receiver will understand that this escape character is extra data which is added by the sender. So receiver will remove that escape character and receiver will keep the data which is after the escape character as a part of the frame. Receiver will not remove the flag like data. Okay? Now you can say that, sir, there is also possibility that in the frame there is a data like escape character is present. Yes, you are right. There is also possibility that in the frame the data like escape character is present. So when there is a data like escape character is present in the frame, the sender will not send the frame, because if sender sends this frame directly, what receiver knows is that to remove the escape character. Whenever receiver detects the pattern of escape character, receiver will remove that escape character. And when receiver removes the escape character, actually the part of the frame will be removed. So before sending this frame, the sender will add one more extra escape character and it will send to the receiver. Now when receiver receives the frame and when receiver encounters the first escape character, it will remove the escape character and it will keep the data after the escape character as a part of the frame. So you can understand that the actual data, which is just like an escape character, is not removed by the receiver. Understand, student? Whenever receiver detects any escape character in the frame, all the receiver knows is to remove the escape character and keep the data after the escape character as a part of the frame. Now there is also a possibility that in the frame both the data like escape character and flag is present. Now what will happen if in the frame both data like escape character and flag is present? The sender will add one escape character before the data like escape character and one escape character before the data like flag. So when receiver encounters the first escape character, it will just discard it and it will keep the data after that escape character as a part of the frame. When receiver detects one more escape character, it will discard it and it will keep the data after the escape character as a part of the frame. Okay, so this is how the framing method works. Now there is also possibility that two escape character like data is present in the frame. So I think you get it that 4 escape character will be there before sending the frame. Okay. Now let's see the last method, which is bit stuffing. Now how the bit stuffing works. When sender finds that in the frame there are 5 consecutive ones are there, the sender will add extra 0 just after 5 consecutive ones. So the function of the sender is fixed. What is the function of sender? When sender finds 5 consecutive ones in the frame, it will stuff extra 0 after 5 consecutive 1. Okay? What will do when the receiver finds the 5 consecutive ones in the frame? So when the receiver finds 5 consecutive ones in the frame, the receiver will remove 0 from the frame. So you can see that this is the data which is sent by the sender. Now you can see that there are so many 5 consecutive ones are there. So after 5 consecutive ones, the sender will stuff the 0. After 5 consecutive ones, the sender will stuff the 0. Okay, and this data will be sent to the receiver. When receiver receives the data, it will remove 0 after 5 consecutive 1. So in the bit stuffing, the function of the sender is to add 0 after 5 consecutive ones, which is fixed. Whenever sender finds 5 consecutive ones, it will add 0. At the receiver side, whenever receiver finds 5 consecutive ones, it will remove 0 after those 5 consecutive ones. So this is it for the framing. If you have any doubt, you can ask me in the comment section. Thank you so much.